Hi there, this is lesson 1.3, first look at variables. A statement, such as x equals 5, seems obvious enough. As you would guess, we are assigning the value of 5 to x. But what exactly is x? X is a variable. A variable in C++ is a name for a piece of memory that can be used to store information. You can think of a variable as a mailbox or a cubbyhole where we can put and retrieve information. All computers have memory called RAM, short for random access memory, that is available for programs to use. When variable is declared, a piece of that memory is set aside for that variable. In this section, we are only going to consider integer variables. An integer is a whole number such as 1, 2, 3, minus 12, or 16, for example. An integer variable is a variable that can only hold an integer value. Now, in order to declare a variable, we generally use a declaration statement. Here's an example of declaring a variable x as an integer variable, one that can hold integer values. Here we go, int x. When this statement is executed by the CPU, a piece of memory from the RAM will be set aside. For the sake of this example, let's say that the variable x is assigned memory location 140. Whenever the program sees the value x in an expression or statement, it knows that it should look at memory location 140. One of the most common operations done with variables is assignment. To do this, we use the assignment operator, more commonly known as the equals symbol. When the CPU executes a statement, such as x equals 5, it translates this to put the value of 5 in memory location 140. Later in our program, we could print that value to the screen using cout and doing something like cout x, which will print the value of x, in other words, the memory location 140, to the console. In C++, variables are also known as L-values. An L-value is a value that has an address in memory. Since all variables have addresses, all variables are L-values. They were originally named L-values because they are the only values that can be on the left side of an assignment statement. When we do an assignment, the left-hand side of the assignment operator must be an L-value. Consequently, a statement like 5 equals 6 will cause a compiler error because 5 is not an L-value. The value of 5 has no memory, and thus nothing can be assigned to it. 5 means 5, and its value cannot be reassigned. Whether an L-value has a value assigned to it, the current value is overwritten. The opposite of L-values are R-values. An R-value refers to any value that can be assigned to an L-value. R-values are always evaluated to produce a single value. Examples of R-values are single numbers such as 5, which evaluates to 5, variables such as x, which evaluates to whatever number that was last assigned to it, or expressions such as 2 plus x, which evaluates to the last value of x plus 2. Here's an example of some assignment statements showing how the R-values evaluate. In y. This will declare y as an integer variable. Y equals 4. 4 evaluates to 4, which is then assigned to y. Y equals 2 plus 7. 2 plus 7 evaluates to 9, which is then assigned to y. Declare x as an integer variable. Y evaluates to 9, which is then assigned to x. X evaluates to 9, which is then assigned to x. This is useless. X equals x plus 1. X plus 1 evaluates to 10, which is then assigned to x. Now, there are two important things to note. First, there is no guarantee that your variables will be assigned the same memory address each time your program is run. First time you run your program, x may be assigned to memory location 140, as we said. The second time, it may be assigned to memory location 168. Second, when a variable is assigned to a memory location, the value in that memory location is undefined. In other words, whatever value was there last is still there. This can lead to interesting, and by interesting I mean dangerous, results. For example, consider this short program. By the way, if you're using Microsoft Visual Studio, don't forget to include stdafx stdafx.h. I commented this line because I'm using Xcode on a Mac. Okay, so our program will look something like this. Int main, let's remove that and say using namespace std. I'm going to comment again to remind you what these does. This will give us access to cout and cin. Excuse me, and line. Forget about cin for now, I'm going to explain that later. In x, this will declare an integer variable named x. Now, print the value of x to the console. Dangerous, since x is uninitialized. Okay, so to print that value of x, we say cout x, and let's say end line. Now, in this case, the computer will assign some unused memory to x. It will then send the value residing in that memory location to cout, which will print the value. But what value will it print? Well, the answer is who knows. You can try running this program in your compiler and see what it prints. To give you an example, when I'm running this program, I would say something like this. Run. I got the value 0. That's not necessary for your case. A variable that has not been assigned a value is called an uninitialized variable. Uninitialized variables are very dangerous because they cause intermittent problems due to having different values each time you run the program. This can make them very hard to debug. Now, most modern compilers, probably like the one you're using and the one I'm currently using, will print warnings at compile time if they can detect the variable that is used without being initialized. For example, compiling the above program on Xcode produces the following warning. Variable x is uninitialized when used here. You can see it's always in yellow, which means this is a warning and not an error. Now, a good rule is to always assign values to variables when they are declared. C++ makes this easy by letting you assign values on the same line as declaration of the variable. So instead of saying int x, we could say int x equals 9. No reason to put 9, but for example, this is an initial value for x. So this will declare integer variable x and assign the value of 9 to it. This ensures that your variable will always have a consistent value, making it easier to debug if something goes wrong somewhere else. Now, one common trick that experienced programmers use is to assign the variable an initial value that is outside the range of meaningful values for that variable. For example, if you had a variable to store the number of cats the old lady down the street has, we might do the following. Int cats equals -1. Now, having -1 cats makes no sense. So if later we did something like cout cats, and line, and let's delete these, and run the program, we'll read -1 cats. Now, we know that the variable was never assigned a real value correctly because it printed -1. So take it as a rule, always assign values to your variables when you declare them. Now, we will discuss variables in more detail in an upcoming lesson. Let us talk about another topic, which is the cin. Cin is the opposite of cout. Whereas cout prints data to the console, cin reads data from the console. Now that you have a basic understanding of variables, we can use cin to get input from the user and store it in a variable. So I'm going to leave the same example, include iostream int main using namespace std, but now I'm going to say, I'm going to do something like cout enter a number. Then I'm going to declare a variable x, and I'm going to say cin x. This will read number from the console and store it in x. Then I'm going to print to the console you entered x, end line. Return 0. Let's compile this program and running it to see what happens. Enter a number. You can see the program has stopped and wait for me to enter a number. Let's say I'm going to put 43. Enter. You entered 43. Now, once you enter a number and press enter, it will print you entered followed by the number you just entered, just like it happened with me. Now, this is an easy way to get input from the user, and we will use it in many of our examples going forward. This is the end of lesson 1.3. See you next time.